Hey guys, so today we're covering 6.2 of chapter 6, and that describes the circumcenter theorem. So if you are looking at this triangle on your page, you are told that PE, PD, and PF are all perpendicular bisectors, okay? They're all perpendicular bisectors of each side. So they create, when they come together, the perpendicular bisectors create the circumcenter. So the circumcenter is created by perpendicular bisectors, and it is actually equidistant from each vertex. So the circumcenter here is equidistant from point B as it is to point C as it is to point A. So the circumcenter is equidistant from each vertex. Okay, so that's the circumcenter theorem. Okay, the in-center theorem is the in-center is created by angle bisectors of the triangle. So these are all angle bisectors. AP, BP, CP are all angle bisectors coming together at the in-center. Okay, in-center. And it's created by angle bisectors. And the fun fact about the in-center is that it is equidistant from all three sides. So if you look, okay, the in-center is equidistant from all three sides. All three of those are the same distance. All right, so we have the circumcenter that's created by perpendicular bisectors and is equidistant from the three vertices, right? Okay, and then we have the in-center that is created by angle bisectors and is equidistant from all three sides. Okay, so we know how each one was created and one fun fact about it. All right, we're going to use those fun facts to do the extra practice problems. So, point N is the in-center of, this should be triangle ABC. Use the given information to find the indicated measure of the sides. So, if N is the in-center, that means N is equidistant from all three sides. So, that means ND is congruent to NE, which is congruent to NF, and they're asking us to find NF. So what I would do to find NF is I would set ND and NE equal to each other to figure out what X is. 2x minus 5 is equal to negative 2x plus 7. I would add 2x to both sides to get 4x minus 5 is equal to 7. Add 5 to both sides. You get 4x is equal to 12, and divide by 4. X is equal to 3. Okay, but I'm not done yet. Okay, I know what X is, but I need to find the length of NF. So I could find the length of ND or NE because they're all congruent. So I'm going to plug it into the ND equation. Oh, no, that's wrong. There we go. I'm going to plug it into the ND equation, So 2 times 3 minus 5. Okay, 2 times 3 is 6 minus 5, which makes NF equal to 1. Okay, so since all the sides are equidistant, that allowed me to set them equal to each other to find x, and then it also allowed me to plug x into one of the equations to find NF. Okay, and we'll be doing something similar for number 2. They want me to find NJ. Well, NJ is congruent to NH and NG because point N is the in-center. So I can set the two equations equal to each other just like before. I can solve for x. And I get x is equal to positive 5. Okay, now they want me to find NJ. So since NJ is congruent to NH and NG, I can plug 5 into either equation. So I'm going to plug it in for NG. 5 minus 1 is equal to 4. So NJ has to be equal to 4 because it's also congruent to NG, right? Okay, so again, since N is the in-center, okay, I could set all three sides, all three segment lengths equal to each other and solve for x, and then I can plug it back in to find the length of NJ. And the last one, okay, once again, N is the in-center, so it is equidistant from all three sides. That allows me to set my two equations equal to each other. I subtract x from both sides. I get 10 is equal to negative 3x plus 1. Subtract 1 from both sides. I get negative 3x is equal to 9. Divide by negative 3. And I get x is equal to negative 3. Okay? Now, if x is equal to negative 3, I can now find NK by plugging in negative 3 for x plus 10. Negative 3 plus 10 is 7. So if NK is equal to 7, that means NM is equal to 7. So I've essentially found NM, the question I was looking to solve all along. Okay? All right, so that takes care of the in-centers. Now, in parts 4, 5, 6, and 7, you have to figure out, is this an in-center or is this a circumcenter? Okay? So, looking at number 4, okay, it seems that this point is created by perpendicular bisectors. It is perpendicular to each side and it bisects each side. So we're created by perpendicular bisectors, which means number 4 is a circumcenter. Okay? And the fun fact about circumcenters is that it is equidistant from the vertices. So all of these orange lines are congruent because the circumcenter is equidistant from the vertices. So that means if PB is 13, PC is 13, and then therefore PA must also be 13. Okay? Looking at part 5, okay, this is part 5, okay, point P seems to be created by angle bisectors, okay? So PD, PE, and PF are all angle bisectors that create the point at the middle, which we like to call the in-center. Okay, the reason I knew they weren't perpendicular bisectors was because there were no marks here and here. If there's nothing indicating that the side length has been bisected, then we can't conclude that it's a perpendicular bisector. Okay? So all we know is that it's an incenter created by angle bisectors. But since we know that, we also know that it is equidistant from all three sides. So all of these orange lines are equidistant. So if PU is 8, that means PT is 8, and PS is also 8. Okay, you just have to be careful to make sure you know what created the point of concurrency in the middle, whether it was angle bisectors or perpendicular bisectors. Okay, so here we have an odd looking triangle. Okay, I'm going to highlight our triangle in pink. Okay, here is our triangle right here. It's an obtuse triangle. So when we draw the perpendicular bisectors, which I'll highlight in green, okay, when these perpendicular bisectors are drawn, they actually meet outside of the triangle. Okay, so then when you're measuring right now we're looking at perpendicular bisectors which create a circumcenter. So when you're looking at a circumcenter, okay, you know that a circumcenter is equidistant from the vertices, which I'm highlighting in orange right now. Okay, circumcenter is equidistant from the vertices. So if GD is 10 units long, GE must also be 10 units long because point G is the circumcenter. Okay. Okay, number 7. All right, number 7, we have angle bisectors.
You want to go get a stop?
Okay, angle bisectors are creating the incenter at point N. Okay, the incenter at point N is going to be equidistant from the sides in orange. So if NE is 2, ND is 2, NF must also be 2. Okay, so NF is equal to 2. Okay, hopefully this is giving you a better idea of what a circumcenter and incenter is and what a circumcenter and incenter creates. A point that is equidistant from each side. Okay, now in exercises 8, 9, and 10, they want you to find the coordinates of the circumcenter of the triangle with the given vertices. Okay, so what we're going to do is we're first going to plot our coordinates. Okay, so we're going to focus on number 8 for right now. All right, so we have coordinates at, well, first we need to create our grid. I think I can add one. Oh, we have a grid. Okay, first we need to create our coordinate planes. Okay, I'm going to make those a little bit darker and in black. So I'm going to create a coordinate plane. It's got to be here. Okay, this long by about, oh wow, Kels, you're killing me. I'm going to redraw that. Okay, so we have our x-axis. That's a little bit better, and I think if I hold it, it creates a straight line. Good. So there's my x-axis, and then my y-axis I'm going to put over here because I know that I have to go up to positive 6. So I'm going to put that there. There's my y-axis. Okay, x, y. All right, now I'm going to start to graph my original triangle in blue. So I have a point at -2, -2. That's going to be point A. I'm going to have my point B at -2, +2, 4. That's going to be point B. And then I'm going to have point C at +2, 4, 6. Right, 2, 4, 6, +2, 4, point C right here. Okay, so this is my triangle. Okay, and as you can see, it is a right triangle. Okay, and we need to create the circumcenter. Okay, now if we go back and look, the circumcenter is created by perpendicular bisectors. Okay, so what actually is going to work out in our favor is the fact that it's a right triangle. Okay, since it's a right triangle, we really only need to find 2 of the points and where they meet. And then the other point will obviously meet at the third line will obviously meet at that section. Okay, at that intersection. So I'm looking at BC right now, and I'm realizing it's 1, 2, 3, 4, 5, 6, 7, 8 units long. So to bisect it, I would have to count 1, 2, 3, 4. Okay, and a perpendicular bisector, since it's a vertical line, a perpendicular bisector would be, or since it's a horizontal line, a perpendicular bisector would be a vertical line. Okay, now I'm going to look at AB. 1, 2, 3, 4, 5, 6. Okay, it's 6 units long, so to bisect it would be at 1, 2, 3 units. And since it's a vertical line, a perpendicular bisector would be a horizontal line. Okay, now, since we've found our point of intersection, we really don't need to go much further to say that our circumcenter is right there. Ooh, pardon my handwriting. Okay, so our circumcenter is at +2, +1. Okay? All right. Let's try number 9. Feel free, if you're feeling comfortable, feel free at any time to try it on your own. There is no need to wait for me if you feel like you've got this. So number 9, all right, it's all of our numbers are positive. So I'm just going to create the first quadrant. Okay, so I've created the first quadrant, my x-axis, my y-axis. Okay, and now I'm going to graph my triangle in blue, and I'm going to try to make actually, no, that's fine. All right, so I have a point at +3, +2, 4, 5. That's going to be point D. Okay, I have a point at +3, +1. That's going to be point E. And I have a point at +3, 6, 9, +5, which is going to be point F. So here is my triangle. Okay, and again, I'm asked to find the circumcenter, which is essentially created by perpendicular bisectors. So I am again going to count how long the line DF is. 1, 2, 3, 4, 5, 6. Half of 6 units is 1, 2, 3 units. So, and perpendicular to a horizontal line is a vertical line. So I've created my perpendicular bisector of DF. Now I need to make a perpendicular bisector of DE. So it's 1, 2, 3, 4 units long. Halfway between 4 units long would be 2 units long, and perpendicular to a vertical line would be a horizontal line. So I've created my perpendicular bisector for DE as well. Both of them are meeting at the point where they're intersecting. Okay, they're intersecting at 1, 2, 3, 4, 5, 6, +6, +3. Okay, and that point 6, 3 is going to be our circumcenter. All right, so let's try the last one. Okay, number 10. So I'm going to create my grid to the best of my ability. All right, so we have to get down to -7. So everything for my y's is below the y-axis. So I'm going to put the y-axis here. And then I only need to go up to +4 for my x. So 1, 2, 3, 4 would bring me here. So there's my x-axis, there's my y-axis. Okay, and now I need to graph my my triangle. Okay, so I have a point at +4, -2, 4, 6, 7. That's point J. I have a point at +4, -3. Okay. And last I have a point at -6, -3. So 2, 4, 6, -3 is here. That's L. All right. So again, I have a right triangle. These are the easiest types of triangles to deal with, so that works out nicely for us. Okay, I have a right triangle that I have to create perpendicular bisectors of. So, again, we need to count our horizontal line, LK. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Half of 10 is 5, so 1, 2, 3, 4, 5. Perpendicular to horizontal is vertical. There we have, there we have our perpendicular bisector. Oh, maybe I'll just undo that. There we go. Draw it again. Now we have a perpendicular bisector. Okay, KJ is 1, 2, 3, 4 units long. Half of 4 is 2. Okay, and here we have another perpendicular bisector. Okay, so two perpendicular bisectors meet at the incenter, which is right here. Okay, and our incenter seems to be at -1, -1, 2, 3, 4, 5, -5. That is our, oh, did I say incenter? I meant circumcenter. The circumcenter is created by perpendicular bisectors. Okay, so that, my friends, is chapter 6.2, circumcenters and incenters. 6.3 covers the centroid, and at the end of 6.3, I'd like to make a chart with you that outlines circumcenter, incenter, and centroid. All right, so I'll see you for 6.3.